here we need to evaluate the expression that we have a complex number at the bottom of the fraction. So we don't want to have any I or radical at the bottom of the fraction. So for these problems here, you need to multiply the top and bottom of the fraction by conjugate of 1 minus 5i. Every time you multiply a binomial, a plus b, by its conjugate, which is a minus b, then you would create difference of square. So here you have a squared minus b squared. Now these square would eliminate any complex number or radical that you may have in your binomial. So in this case, I need to multiply the top and bottom of the fraction by conjugate of 1 minus 5i. The conjugate of 1 minus 5i is 1 plus 5i. We do this if you have binomial, if you have two terms at the bottom of the fraction. If you have only one term at the bottom of the fraction, you would just simply multiply it by itself. If you have only I or 2i at the bottom of the fraction, you multiply by itself, 2i, and then I squared turns to negative 1. But in this case, since you have two terms, we need to multiply that by its binomial. So let's see what we get. At the bottom of the fraction, I have a minus b times a plus b. You know, it's equal to a squared minus b squared. My a is 1, so it would be 1 squared minus my b is 5i. Okay, put 5i squared. All right. Now the top of the fraction, we would get 2 plus 3i times 1 plus 5i. We don't care if you get I at the top of the fraction or if you get radical at the top of the fraction, not bottom. So at the bottom fraction, I get 1 squared, which is 1, minus, this would be 25i squared. If you recall, I squared is equal to minus 1. So if I replace I squared with minus 1, at the bottom of the fraction, looks like I would get 1 minus, then minus 25 would be plus 25 then, right? That would be 1 minus 25 would be 1 plus 25. So I would get 26 at the bottom of the fraction. I eliminate the I at the bottom of the fraction by multiplying it by its conjugate. Now at the top of the fraction, again, we just have to multiply these and see what we get. Here I have 1 times 2 is equal to 2. 2 times 5i give me plus 10i. And then we continue with distributing. You get 3i plus 1 would be plus 3i. And finally, we get plus 15. I times I would be I squared. Again, I squared is equal to minus 1. So this term here turns to minus 15, which can be combined with this constant here, plus 2. And then we need to add the like terms, 10i plus 3i. That give me a total of 13i. So I'm going to write this as the real numbers first. Minus 15 plus 2, that give you minus 13. That's the real part. Then we have plus 13i over 26. I can leave the answer just like that. But if you want to write it as a plus bi, that's the standard form to write the complex number. We can separate these. My real part would be minus 13 over 26. Can I reduce that? Yes, plus 13i over 26. We do definitely need to reduce at the end. So here I get minus 1/2 as my real part. Then here goes plus 1/2 I Or if you want to write it as one piece, would be minus 1 plus I over 2. Either of these would be acceptable. This is a standard form, and this is a reduced form. So for this kind of problem, we need to multiply by its conjugate, and don't forget I squared would be equal to minus 1, and the goal is to not have any I at the bottom of the fraction. Here we want to determine the number of real solutions. They're not asking us to solve for this. I just want to know how many real solutions do we get. So the first thing we need to do is to write this as standard form ax squared plus bx plus c is equal to 0 when writing this form. So in this case, I'm going to write that leave 2x squared alone, subtract 5x from both sides of the equation. So I get 5x to the left, add 3 to both sides of the equation. So I'm going to get into standard form. In order for you to have real solution, the discriminant, which is b squared minus 4ac, if it is equal to 0, then you get the identical solution, if you recall. If it's greater than 0, then we get 2 real solutions. If it's less than 0, then we get a complex solution. And that b squared minus 4ac really comes from that quadratic formula. If you remember, x is equal to minus b plus and minus square root of, this is where the b squared minus 4ac come from. That's the discriminant, they call it over 2a. So we don't want to have what we have under the radical to be negative, because if you do, then we get complex numbers. So if you get a negative, you get 2 complex solutions. If it's greater than 0, you get real solutions. If equal to 0, then we get identical solution. You get one solution. Minus b over 2a would be the only solution. So in this case, let's identify which is your a then is equal to 2. Your b is equal to -5. And your c is equal to 3. So we need to evaluate b squared minus 4ac. So my b is -5, so I get -5 squared. -4, my a is 2. And my c is 3. Let's evaluate that. What we get here, we have 25 plus 25. If I multiply these 3 terms together, we get minus a number, right? We get 2 times 4 is equal to 8. 8 times 3 would be minus 24. So it looks like b squared minus 4ac would equal to plus 1. Since plus 1 is positive, since b squared minus 4ac turns out to be equal to 1, and that is greater than 0, then we conclude here we get 2 real solutions. We get two real solutions here. Here we need to determine the number of solutions. This is already in the standard form. So if you recall, we're gonna evaluate b squared minus 4ac to see if it's greater than 0, less than 0, or equal to 0. In this case, my a is the coefficient of x squared, which is 1. My b is equal to 1. That's coefficient of x. And my c is the constant -4. Let's go ahead and substitute these values here. b is equal to 1. That would be 1 squared minus, here we have 4 times your a is 1 and your c is -4. So here I get 1. I should get a plus here. We have 2 negatives here, plus 16. So that is also equal to positive number. That would be 17. So since b squared minus 4ac is equal to plus 17, and 17 is greater than 0, here we get two real solutions. Okay, here it says find the remainder. So we're dividing x plus 1 into this polynomial. One way to find the remainder obviously is to divide. Set the long division. Remember we learned how to do long division. X plus 1. I'm not gonna use long division though, but I'm going to show you. If I go ahead and set up the long division like that, you should know how to divide this and find the remainder. We talked about that. Another way was synthetic division. Remember the synthetic division? For synthetic division, we're gonna write these in order first. With the long division, we also suggested that put 0 for the variables are missing. So here we have x to the power of 4. So this was optional here. Plus x to the power of 3 is missing, right? So I can put 0 x to the power of 3 just to recall that x to the power of 3 is not there. And then x to the power of 2 is not there. I'm going to put 0 there. The reason it's not there is because its coefficient is 0. And then the next one is x is present and so as a constant. And we proceed. Now with the synthetic division, we have to include those zeros. So we only put the coefficients of these, which is 1. Coefficient of x to the power of 4 is 1. Coefficient of x to the power of 3 is 0. And then coefficient of the x to the power of 2 is also 0. We're going to recall all that. And then coefficient of x is 3. And then we have the constant minus 8 here. And then anybody remember what we had to put here? What number you have to put here? Plus 1 or minus 1? Anyway, kind of like opposite of this number you see here. Here is really x minus 1. Your k is minus 1 if you recall. So you can remember that would be always opposite of this. So if this were x minus 1, then this would be plus 1. All right. So if I perform this synthetic division, then I can find the remainder also. However, we had one property, if you remember, if I find f of minus 1, if I find f of minus 1, whatever number I get here, that would be my remainder without dividing using long division or synthetic division. Okay? So if this were x minus 1, then you will have to evaluate f of plus 1 in order to find the remainder. All right, let's go ahead and find what this f of minus 1 is here. Okay, so in this case, you have f of x is equal to x to the power of 4 plus 3x minus 8. That's your f of x. So f of minus 1 then would be substituting for each x minus 1. Let's do that. Minus 1 to the power of 4 plus 3 to the power of minus 1 minus 8. So I would get 1 here plus 1. Then you get minus 3 and minus 8. Okay. So I get 1 minus 3, that gives me minus 2, minus 8. So it looks like f of minus 1 is equal to minus 10. That is my remainder. So let's go ahead and use synthetic division since it's pretty easy to follow. If you recall, we're going to bring the 1 down here. Again, you don't have to do this. We multiply these two together and place it right here. They give you minus 1. So you get 0 times minus 1, I mean 0 plus minus 1 give you minus when you add them. And you continue with this process. You multiply these two together and place it here. They give you 1. 0 plus 1, they give you 1. All right, keep on going with this method here. We're going to go minus 1 times 1 would be minus 1. We add these up, 3 minus 1 give you 2. And the last step, you multiply again. And minus 1 times 2 give you negative 2. And if you add these up, you see the remainder becomes minus 10. Same exact number that we calculated using this. So it's a lot easier perhaps to just find f of minus 1 to come up with the remainder rather than using the long division or synthetic division. For this problem here, you want to find p of k for p of x is equal to x squared plus 3x minus 10. Your k here is minus 3, so you want to find p of k, which turns out to be p of negative 3 then. So p of k, since k is equal to negative 3, is evaluating p of negative 3. And that's all you need to do is to substitute for each x negative 3. It's like somebody asked you to evaluate this expression when x is equal to negative 3. All right, we just substitute for each x negative 3. Then here we get 9. Negative 3 squared would be plus 9. Then here 3 times negative 3 would be minus 9, minus 10. So these add up to 0. So p of negative 3 is equal to minus 10. Is negative 4 a 0 of this polynomial? Justify your answer. If negative 4 is a 0, means actually the solution x would be equal to negative 4. When the solution is negative 4, means one of the factor then must be x plus 4, if that's the case. If negative 4 is a solution, one of the factor of the polynomial would be, must be x plus 4 then, right? If I solve x plus 4 for x less than or equal to 0, x would be equal to negative 4. This is my 0, this is my factor. So if it is a factor, if I divide x plus 4 into this polynomial, my remainder would turns out to be equal to 0. Right? So if the remainder turns out to be equal to 0, this would be the factor and this would be the zeros. So in order to x minus 1 be equal to 0 of the polynomial, you have to figure out whether we get a 0 as a remainder. If you get the 0 as a remainder, the answer would be yes. X plus 4 would be the factor, therefore x would equal to negative 4 would be the 0 of the polynomial. So pretty much we need to either divide this polynomial by x plus 4 using long division or synthetic division. That would be a long way of doing that. Or use the fact that if I evaluate p of minus 4, if I evaluate p of minus 4 and this turns out to be equal to 0, what that means is that the remainder would be equal to 0. If the remainder is equal to 0, therefore x plus 4 would be a factor, and then x equal to negative 4 would be one of the zeros or solution of that polynomial. So that's all you really need to do is evaluate p of negative 4 and see if it turns out to be equal to 0 or not. If it's 0, then yes, the answer is negative 4 is a 0, otherwise it's not. So let's go ahead and substitute that value there. So here I get 6 times, I'm going to substitute for each x minus 4 plus 25 times, again, minus 4 squared plus 3 times minus 4 here. So we need to evaluate this. So we get 6 times negative 4 to the power of 3, give me negative 64. Then here I have plus 25 times negative 4 squared, give me 4 times 4 would be 6 plus 16. That would be minus 3 times 4 would be 12 minus 4. So you can work this out. You get 6 times minus 64. I give you minus 384. And then plus, you get 400 minus 12 minus 4. And then here I get 16 minus 12 minus 4. Looks like it is going to be equal to 0. 4 minus 4. Yes. Since P of minus 4 turns out to be equal to 0, so the answer is yes. The remainder is 0. Then minus 4 is a 0. One of the 0 of the polynomial. In other words, x plus 4 is one of the factor of that polynomial. Find a polynomial function having the following zeros. So if I know the zeros or the solutions are radical 3, minus radical 3, 2, and 3, then I would know the factor of the polynomial. If radical 3 is a 0, one of the factor of that polynomial must be x minus radical 3. Right? Because if I solve this for x, what do I get? X equal to radical 3. If minus radical 3 is also a 0, then one of the other factor would be x minus radical 3, right? Which is really x plus radical 3. If 2 is a 0, then one factor would be x minus 2 then. And finally, if 3 is the 0, one of the factor would be x minus 3. So this is the polynomial that we are looking for. I'm going to let it equal to 0. If I multiply these together, I can get my polynomial in standard form. First one, we have x minus b times x. It just kind of look like the difference of square if I go ahead and expand this. So let's go ahead and do that. The first one is x minus radical 3 times, let's write it as x plus radical 3. This is difference of square now. So I don't have to multiply term by term. This would be the first term square minus the second term square is radical 3 squared, which is equal to just 3. Okay, so this would be the result of the product of the first two parentheses. The next two here, I can multiply term by term and combine like terms. X times x would be x squared. Last term, negative 2 times negative 3, that give me 6 plus 6. Now if I multiply the two closest term and two furthest term, I would get negative 2x, negative 3x, that give me a total of negative 5x. It's multiplying term by term, combine like term. So here I get x squared minus, this would be just 3, times x squared minus 5x plus 6. All right, I need to multiply term by term. I get x to the power of 4 minus 5x to the power of 3 plus 6x to the power of 2. Continue with negative 3 the same way. Negative 3x to the power of 2 plus 15x minus 3 times 6, 18. So all I have to do now is combine like terms. We only have 1x to the power of 4. And then we have only 1x to the power of 3. We have two terms with x to the power of 2 on it. So it would be 6 minus 3. That would be plus 3x to the power of 2. You only have one of each of the rest, would be 15 plus 15x minus 18. That is equal to 0. So this is the polynomial that would result into having these zeros. Okay. It's given that if 2i is a zero of this polynomial, then find all linear factor of p of x. So if 2i is, if one of the zero, if x is equal to 2i, then one factor of this polynomial then must be x minus 2i. Right? If 2i is a 0, one factor would be x minus 2i. With the complex number, if a complex number like 2i is a 0, its conjugate also is another 0. So if I know that 2i is 1, 0, then I should know automatically that minus 2i also must be my other 0. Then my other factor then must be x minus 2i then. In other words, my factor so far is 2 minus 2i times x plus 2i. My factors are x minus 2i times x plus 2i, and which this is a difference of a square really. So yeah, first term is x would be x squared minus the second term square is 2i squared. So I would get x squared minus 4i squared. Remember, I squared is equal to minus 1. So it would be x squared minus 4 times minus 1. So we have x squared plus 4. So this must be a factor of the polynomial p of x. If x squared plus 4 is a factor of this polynomial, if I go ahead and divide that, you can use either synthetic division or long division. You can find the other factors then. So for part A, you want to find all the factors. There are two ways you can do this. You can divide x squared plus 4 using the long division by my polynomial, which is 2x to the power of 4 minus x to the power of 3 plus 7x to the power of 2 minus 4x minus 4, or you could use synthetic division. Okay, for the synthetic division, we need to copy the coefficients, which are 2 minus 1, 7 minus 4, and minus 4. Anybody remember what should I put here? Plus 4 or minus 4? Minus 4, very good. Opposite of what you see there, minus 4. And then this looks simpler to follow. I'm going to go ahead and use the synthetic division. I'm going to bring the 2 down here and multiply and place that product right below minus 1. Minus 4 times 2, they give me minus 8. We add minus 1 and minus 8, they give me minus 9. We continue with this process. Minus 4 times minus 9, they give you 36. You add these up, you get 43. You multiply minus 4 by 43, give you minus 172. You add them up, you get minus 176. And the last step, you multiply again, minus 4 by minus 176. You get 704. And then here you get 700. The remainder would be 700. This would be for part B, really. It says if P of X is divided by X plus 4, what is the remainder? Okay. So if you did multiply this here using the long division, so the remainder would be for part B. This really is part B. We find P of minus 4 is equal to 700. The remainder would be 700. And for part A, we can go ahead and do the long division here. So that would be a good practice since we need to know how to do long division. Let's go ahead and do that. Get x squared plus 4. And then we're going to set this up as long division. For those of you watching this later at home or following this with me right now is a good time to see if you can get the same answer. Those of you at home, you can pause the session and see if you can get the same quotient here. So here we go. What times x squared give you 2x to the power of 4? That would be 2x to the power of 2. And then you multiply, you get 2x to the power of 4. And I give you plus 8 x to the power of 2. Okay, and then you need to subtract, right, to find the remainder. And if you recall, when you distribute this minus, the subtraction would change the sign of this to its opposite sign. So I get minus x to the power of 3 here. All right, you need to combine like terms, so be careful with adding these. You have 7x squared minus 8x squared. They give you minus 1x squared. You can bring the rest of the terms down and continue. What times x squared give you minus x to the power of 3? They give you minus x. So that would give me minus x to the power of 3. And then give me minus 4x. Once again, we need to subtract. You change subtraction to addition, and we change the sign to its opposite sign. And then x cubed adds up to 0. Then we get minus x squared plus 4x minus 4x adds up to 0. You have a minus 4 down here. And then the last term here would be minus 1. And as you can see, the remainder would be 0. We do get a remainder of 0 here. So what that means is 2x squared minus x minus 1 must be another factor of this polynomial then. Okay. Which I can factor this. This is factorable. You can factor to 2x and x. Then here you put 1 and 1. Get 1x and 2x. You want to get minus 1, that would be plus. That would be minus. There we have all the factors then. For all the factor of polynomials would be for P of x, for part A. Let's use a different color here to bring this up. So for part A, the factors that we have is x minus 2i. That's one factor. The other factor would be x minus minus, so it would be x plus 2i. That would given to us. And the next factor we find was 2x plus 1. And then the other one we find is x minus 1 now. We find all the factors of that polynomial for part A and B. And for part B, we just simply find that remainder to be equal to 700. And that was part B. Given the graph of f of x is equal to x squared plus x minus 2, we want to solve f of x is equal to 0. So if this is my function f of x, wherever this function intercept x-axis, those would be my x-intercept. So it looks like to me that this graph intercept at point x equal to 1. Also intercept as x is equal to -2. So if I want to solve this for f of x equal to 0, I get two solutions. X is equal to 1 or x is equal to -2. It's really important how to present the final answer here. You can leave the answer like this, x is equal to 1 or x is equal to -2. Another way you can write this is you can use a brackets. Brackets means all the solutions of the equation can be listed here, separated by comma. Now brackets is the same as saying x equal to 1, x equal to -2. You cannot use this symbol here, for instance. Or we cannot use these symbols here because none of these really tells you that you get two solutions. These are the interval notation. This means all the numbers between 1 and -2. This means all the numbers between 1 and -2, not including the endpoints. Okay, so make sure you know the difference between the interval notation when would be a range of numbers between 1 and -2, and then use brackets like this to indicate we only have two solutions. For part A, you can either write the final answer like this, x equal to 1 or x equal to -2, or you can put it inside this brackets like that. For part B, solve f of x is less than 0. So we're going to look and see at what points this graph would be below 0. Okay, less than 0. Okay, take a look. Where is this graph is below 0? Right here, right? Between -2 and 2, the graph would be below 0. So this would be brackets because those endpoints are included. -2, comma 1. Now we're looking at all the numbers from here to here, for this domain, from -2 to 1, this function would be below 0, would be less than 0. Simple as that. For the one greater than 0, then it's pretty obvious, right? Let's use different color for that. For the greater than 0 would be all the numbers from 1 to infinity would be greater than 0. This would be where your function would be greater than 0, above x. And then also this here, all this domain, this portion of the domain would be where the function would be greater than 0. So we can write as the interval notation as all the numbers from -infinity to -2, including -2, or for all we're going to use union. That means union. All the number from 1 all the way to plus infinity, just put infinity. And we're going to use parentheses for endpoints for infinity because the endpoint is not defined. So this would be where f of x is greater than 0. The function defined by f of x equal to 5, x to the power of 3 minus 2, x to the power of 2 minus 5 has, we don't know how many complex 0, and it says at least how many real 0. So in this case, since n is 3, and 3 is odd number, recall an odd function must always have at least one real solution. And then here it says how many, it has 3 complex zeros. The function defined by f of x equal to minus 3x to the power 4 plus 5 has, we want to find the number of complex zeros and real zeros. Minus 3x to the power of 4 plus 5 equal to 0. Let's solve for x. Minus 3x to the power of 4 is equal to minus 5. Subtracting 5 from both sides of the equation. Dividing both sides by minus 3, I get x to the power of 4 is equal to minus 5 over minus 3. So x squared then is equal to plus and minus square root of 5 over 3. So x squared is equal to square root of 5 over 3, or x squared is equal to minus square root of 5 over 3. So x then would be equal to plus and minus, that would be 4th root of 5 over 3, or x is equal to plus and minus 4th root of 5 over 3 times I, because we have this minus here, square root of minus 1 is equal to I. So this function has 4 complex zeros and has 2 real zeros.